right, we're looking at the first scatter plot worksheet, and we were given this table here and asked to create a scatter plot for it. So I went ahead and did that. I put hours on the bottom and I went by twos because we had to get all the way up to 12. And then my resting heart rate, I did break it and then started at 50 and I counted by fives. Now you don't have to do that. That's just how I chose to do it. Okay. Then we're asked to draw a line of best fit for this. Okay. So again, when you do draw a line of best fit, don't make it too crazy. Just make sure you kind of go through the points. You kind of see how they're formed, and then you just, the best you can, kind of go through there. Okay. So there's my line of best fit. If I had to say what kind of association this is definitely a negative association, a negative correlation, right? We're going down as the hours go up. Okay, find the slope of this line. Now, in order to find the slope, we want to find 2 points on here and then either use a slope formula or do some counting, right? So if I look, it looks like I hit this point right here. This was the point 775, according to my data. And then I'm really close to this point. I'll just go ahead and use that. That's the point 12, 55. So I'm using these 2 points here, 775, 12, 55. Okay, so my slope will be y minus y over x minus x, which gives me 20 over -5, or a slope of -4. All right, your slope is probably a little different, and that's okay. You picked maybe 2 different points. But we should be close. Should be -3.7, -4 point something, somewhere in there. We shouldn't be too far away from each other on that. Okay, what does this slope mean for us? Well, each additional hour of exercise lowers our heart rate by 4 beats per minute. I think that's beats per minute is what I'm going to use for that. But basically, the heart rate goes down 4 every time you add an extra hour of exercise per week. That's what we're seeing here according to the data. And that's on average, right? Now, write an equation for the line of best fit. We have a slope, we have a point. I could try to find my y-intercept and do it that way if I wanted. Or I can just use point slope form. So I'll use point slope form here. Y minus 75 equals -4 times x minus 7. I picked this point here and I just used that. Okay. If you wanted to, you could actually say, heart rate minus 75 equals -4 times exercise, maybe E minus 7, something like that. All right, it says using your equation, what is the resting heart rate for someone for 12 hours? So we're going to put 12 in for E. I'm going to get H minus 75 equals -4 times 12 minus 7. And 12 minus 7 is 5. 5 times -4 is -20. And if I add 75 over, now I'm going to get 55 for that. All right, which makes sense because that's actually the point we used, right? 1255, we used that. And so what it's showing is this equation worked. When I put 12 in for E, I got 55 for heart rate. All right, that's the first one. Then the second one had us a certain distance away and the cost for a plane ticket. So I put distance on the bottom, I went by hundreds, and I put cost on the side, I went by 25. So again, it was up to you, but that gave me a decent looking scatter plot here, and it's definitely got a positive association to it. As distance goes up, so does cost. Okay, we've plotted it. Now we're going to draw the line. So again, I'm going to just put it in the best I can. Doesn't have to be picture perfect. We actually would use a calculator to give us the very best line here, and you'll do that in Algebra 2. But for us right now, we're just kind of plugging it in here. Okay, so it says find the slope. So I want to pick 2 points here. That'll be my slope. Looks like this point right here is on the line. That was the point. It looks like we're a little bit over 100. It looks like it's this one, 150, 110. Okay. Now you can see that I didn't really hit any other points out here, right? So the best one, the one that I'm kind of closest to is right here. That's at 800, and it looks like it's just a little under 175. So if I had to guess, maybe I'll go 173. But I'm just kind of guessing on that one, right? You just pick 2 points, and kind of, if you have to estimate, you estimate. So here's our 2 points, 150, 110, and 800, 173. So my slope is y minus y over x minus x, and I'm going to get a negative 63 over a negative 650. Okay, now that definitely doesn't come out nice and neatly, but I'll go ahead and do the division on that on a calculator, and I get 0.0969, so about 0.097 if I round it here. Okay, now what the heck does that mean? Well, it means that we're each mile we add to our trip increases the cost, by 0.097. So basically just about 10 cents, right? If you had to really kind of say this in real terms that makes the most sense, we'd say about 10 cents per mile is what this is saying, okay? So you add 10 miles to your trip, you're adding $1 to your ticket. Add 100 miles to your trip, you're adding $10 to your ticket. That's in essence what we're saying here, okay? So can we write an equation? Again, we could pick one of these points and go y minus y equals slope times x minus x. All right, that works. Or you can pick the other point, or you can try to do the y-intercept, which looks like it's about around 97 or so. If you look here, about 97-ish, 96-ish. And so then you could use that and do it in that form. So what would we predict our plane ticket to cost if we were going 2,000 miles? We're going to put 2,000 in for x. Y minus 110 equals 0.097 times 2,000 minus 150. So you do 2,000 minus 150, multiply it by 0.097, and you should get 179.45. And then we're going to add 110 to that, and so our plane ticket would be 289.45. And I believe that would be a steal if you could get it for that. Most of the time, those are a lot more expensive. But based on our equation, that's what we would say here. All right. Now again, your slope might be different, and your equation is going to be different. Therefore, your answer is going to be different, but it should be close. So don't freak out if it's not the same. You should just have something that's pretty close to what I have. All right?